Imagine dropping an object onto a liquid. What should happen? Simple. It touches the liquid. That's how liquids work. Water touches your hand, coffee touches your cup, rain touches the ground. But under the right conditions, something strange happens. An object can appear to refuse touching a liquid altogether. One of the best places to witness this impossible looking behavior is in a liquid so cold it can instantly freeze almost anything. Liquid nitrogen. Liquid nitrogen is one of the coldest substances most people will ever encounter. At minus 196 degrees Celsius, it can instantly freeze flowers. It can make rubber brittle enough to shatter. So, if you place a warmer object onto your liquid nitrogen, you might expect it to immediately cool down and sink. But instead, something completely unexpected happens. The object glides, slides, sometimes even appears to float, almost as if an invisible force is holding it up. At first glance, it looked like an anti-gravity, but what's really happening is even stranger. The secret isn't inside the object, it's hidden underneath it. When a relatively warm object approaches the liquid nitrogen, the temperature difference is enormous. The liquid directly underneath suddenly boils, not slowly or gradually, but instantly. The liquid transforms into gas. That gas becomes trapped beneath the object. And suddenly, the object is no longer touching the liquid. Instead, it is riding on a cushion of nitrogen vapor, like a hovercraft floating on a layer of air. This phenomenon is known as the Leidenfrost effect. The object and the liquid become separated by an invisible blanket of gas. A layer so thin that you can barely see it, yet powerful enough to completely change how the object behaves. And once that cushion appears, another familiar force almost disappears. Friction. Normally, friction is everywhere. Your shoes grip the floor because of friction. Cars stay on the road because of friction. Even holding your phone depends on friction. But friction requires contact. And now the contact is gone, the object is separated from the liquid by a microscopic layer of gas. Instead of dragging against the surface, it glides effortlessly, just like an air hockey puck floating on a cushion of air. Except this time, nature is creating the cushion automatically. Extreme cold has built its own friction reducing system. But this strange phenomenon raises an even deeper question. What does it actually mean for two objects to touch? Most of us imagine touching as two solid surfaces meeting directly, but reality is much stranger. At the atomic level, matter is mostly empty space. Even when you place your hand on a table, the atoms in your hand never truly merge with atoms in the table. Instead, the electrons surrounding those atoms repel each other. What we experience as touch is actually a force, an electromagnetic interaction. In a sense, physical contact is already far stranger than it appears, and this liquid nitrogen makes that hidden reality easier to see. A microscopic layer of gas becomes enough to completely prevent direct contact. Matter refusing to touch matter, not because of magic, but because of physics. Scientists and engineers use similar principles in many different ways. These effects help cool advanced equipment, improve industrial processes, and reveal how matter behaves under extreme conditions. All from a phenomenon that begins with something refusing to touch a liquid. So, the next time you see an object floating above liquid nitrogen, remember what is really happening. The object is not defying gravity. It isn't being held up by an invisible platform. It is riding on a cushion created by the liquid itself. A layer of gas so thin that it is almost invisible. yet powerful enough to completely change reality. And that is why some objects seem to refuse touching liquid nitrogen.